Hi everyone, am I visible? Like, is my screen visible? Can you guys hear me? Am I audible? Right, okay, so let me start with introducing myself. I'm Avinash Kartik. I'm a master in code forces, and I shall now be explaining to you uh, the problems of the OYO contest. Okay, so the first problem was the minimum cost of the ropes. So I found this problem easier than the second problem, as this problem. Okay, so let me just explain the problem. So what the problem states that you will be given n ropes of varying sizes, and at each step you can like combine two ropes at the cost of suppose the cost of the initial ropes were length of the initial ropes were a of x and a of y. You can combine these both with the cost of cost equal to a of x plus a of y. Right, and the objective for the entire problem is to minimize the total cost. So what we do is if you observe. Okay, can everyone hear me properly? I'm seeing voice problem in the chat. Let me know if you can hear me clearly. Right, okay, then I shall continue. Okay, so suppose you have suppose first let's just reduce this problem. Okay, let's not think about combining all the ropes together. Suppose the problem was you are given n ropes with varying lengths, suppose they are a1 to an, right? So what you have to do is you have to select any two ropes and minimize the cost. You don't have to combine everything together, you just have to combine any two ropes. Now what you do for this is it's obvious that you just have to select the minimum two ropes, and that will give you the minimum cost. As suppose you have x comma y comma z, and this is the order: x less than y less than z. X plus y will be less than y plus z because x is less than z. So you always take the minimum two ropes, and this will give you the least cost. So what you do now is now that we've reduced the problem, so you can do this. You can greedily pick the minimum at each step. So what I mean by this is, so now you have n ropes with a1 to an. Suppose a1 and a2 were the minimum two lengths. In the next step you will have a1 plus a2, like after combining these both, and you will have the rest till an. Now this problem is reduced again to just picking the minimum two elements from this newly formed set. So once we do this operation n minus 1 times, we will have the answer for, we'll have the minimum cost, right? Okay, and more on why this will give the right answer, why greedily picking will give the right answer is, okay, suppose you pick two elements, right? Like you are adding them to the answer, and once you pick these two elements, like you will have to pick them again in a later step. So suppose you pick a1 and a2, you will have to pick them again in a later step to combine it with something else. So you will be adding these two to the answer again. Like suppose you have a3, like, and you combine a1 plus a2, you have a3, and you combine these both, and cost will be a1 plus a2 plus a3, and the cost of the first step was just a1 plus a2. So as you can see, you are adding a1 and a2 twice to the answer now. So the elements that you pick in the initial step will be added more times to the answer than the elements that you pick in the subsequent steps. So like a3 you've picked in the second step and it's just getting added to the answer once, and a1 and a2 are getting added to the answer twice in the first step and in the second step. So naturally, like you can observe that the minimum elements will be picked more times in the answer than the elements greater than them. So hence this gives an optimal answer. Now okay, let me show you how to implement this. So there is something called a priority queue. So you can think of this priority queue as, if you put in n elements, the lesser element will always be on top of the queue, or this is called, it's also known as a min heap, or you can also have a max heap where the greater element will always be on top of the queue. So for this problem, as we need the minimum elements, we implement this using a min heap, right? So I've declared a priority queue over here, and I've inserted all the n elements into the priority queue. Now the answer first will be initialized to 0, and while we have more than one rope, while we can combine two ropes, you keep doing this. Like you pop the two minimum elements and you add those both to the answer, and you push it back into the queue, and again you pop the two minimum elements, and this keeps happening until there's only one string left. So I hope this explanation was clear for this problem. Let me know if you have any doubts, or if I can move on to the next problem. Okay, so I don't think anyone has any doubts, so I'll move on to the next problem. Okay, so the next problem, you are given a triangular pyramid and you have 4 points O, A, B, C, and you start at O, at the point O. Now what you can do is you can either move to its neighboring points. Like all the points are connected to each other. So from O you can move to A, B, C. From A you can move to O, B, C, and from B you can move to AOC, and from C you can move to AOB. So you have to perform these operations. You have to take n steps, right? Okay, so let me just clear the board for you all. Okay, so first you start off at O, and from O you can either go to A, B, or C, and again from A you can go to O, B, and from B you can again go to O, A, and C, and from C you can go to O, A, and B, right? So this is after taking 0 steps, these 3 are after taking 1 step, and these are after taking 2 steps. So if you keep forming this tree, you will you need to know how many O's are there in the nth step. So for example, if n was equal to 2, the answer will be equal to 3, because there's O over here, and O over here, and the paths are OAO or OBO or OCO. These are the 3 ways you can end up at O with n equal to 2. Now if you notice something, like we can group these things, like from this O you will go to ABC again, and from this O again you will go to ABC. So these both, the subtree from this O, like this subtree, and this subtree, both of these subtrees are identical, like this subtree, I mean, sorry, yeah, both these subtrees are identical. So what you can do is you can group these together as like you will if you recursively calculate this, you will calculate this subtree once and this subtree once, which is not efficient because you're essentially calculating the same thing more than one time. So what you can do is you can group this as which level you are in, or number of steps taken, which location you are at, location. Right, so you start off with 0 steps at O, and you can go to with 1 step you can go to 1 comma A, or 1 comma B, or 1 comma C, and so on. You can keep doing this. So if you recursively form this, like let me just try typing it out, like okay. So right, so if you the step and if the step equal to n, you return 1. This is what you do essentially. If the step equal to n and the location is O, like at the end, oh sorry, this is the wrong question. Yeah, so here, okay, so if the step is n and the location is O, and you return 1, or else you can go to any of the other locations. Like suppose it was O, like suppose you are at then you can go to recurse of A plus right, so you can go to any of these 3, like with step plus 1 you can go to A, B, C, and similarly it carries on for the other things. So now instead of writing the location as a variable, so we can map it to something like 0 means O, and 1 means A, 2 means B, and 3 means C. Right, so okay, so int location, plus if you cannot go from this to the same location again, right? Let me name this as next location. Right, okay, so if your next location equal to the current location, you continue because you cannot go to that place. So answer plus equal to recurse of steps plus 1 comma step plus 1 comma. So this recursive function is essentially from A you can go to O, B, C, which step is 2 and so on. Now this recursive solution will again calculate all of these O's separately. So now how you like reduce this is through something called memoization. So memoization is basically once you calculate the value of this, once you find the value of this subtree, you don't calculate it again, you cache it and keep it somewhere, like you store the value. So what I mean is, so suppose let's define a dp of, right, okay, suppose we'll keep dp of x comma y, where x is the steps and y is the current location, right, and if dp of y, if it's -1, then this answer for this location has not been calculated yet, or else it has been calculated. So if dp of location not equal to -1, you just return the value that you have calculated. Right, so instead of answer you can just make it as dp of step, like you're just storing the answer in this variable in dp of step comma location, right, and you return it dp of, and this would be int. And since they want since the path could be very large, they wanted modulo 1e9 plus 7, so you will just have to just modulo it 1e9 plus 7, like I have defined the mod here, let me just define it here, mod, and you return this, right. So this is essentially what you do. But now the location can be at most 4 and the steps can be n, like, so n can be 10 power 6, right. So how do the way to calculate memory complexity for this thing is the number of things you store, and number of things you store is for each step you can have 4 locations. So the memory complexity will be 10 power 6 into 4, which is in order of O of n, but the expected complexity is O of 1, so the solution will pass, but you can do better than this, right. So the time complexity, how you calculate for a recursive solution is the number of states, like you have these states, you multiply both the states, the x can go from x is essentially n, 1 to 10 power 6, and y is basically 4, so 4 into 10 power 6 into how much ever you can, like inside the recursive function, what is the complexity, so over here it's 4, so it'll be 4 into 4 into 10 power 6, which is 4 into 4 into n basically, which is almost O of n time, because you can ignore the constant. So for this so the time complexity, we have matched the expected time complexity with O of n, but we have to improve on the auxiliary space because we are using lots of space for this. So now one more observation you make is that, right, so dp of step and then let me just write L for location, this can only come from dp of step -1 comma some other location, right, because dp of step like we are basically backtracking. So what we did before was from a step to location we go to a step plus 1 to some other location. Now we go this now we are seeing from where all the state can come from. We are defining the dp a little bit differently. So dp of step comma location can come from dp of step minus 1 comma a new location which is not the original location, right? So let me show you. So right, so and yeah, so the observation you make is for step, like while calculating step you only need the step plus 1. You can discard all the other states before, like step minus 2 and step minus 3 and all, you can discard it, as you can you see you only need step minus 1 over here. So you don't have to waste extra memory storing them. So let me just declare like this, like vector dp of 4 for the current step. What is the current dp, right? So I'm not having the other step state right now. And as we know, like we start off in the o, so dp of o equal to 1, right? Because o is mapped to 0 over here, so dp of o 0 equal to 1. And now we have n steps, right? So for these n steps you calculate these new dp. This o can come from either a, b or c, and a can come from o, b or c, and so on. So you just calculate these, and you need to get rid of this dp, right? Because you don't need the old dp with step minus 1. You just need the thing with the current step. So I just swap new dp and dp, so dp becomes whatever we have calculated right now. And after the n steps we just have to return dp of 0, which will tell you the number of ways to go to 0 after n steps. I hope this was clear and you didn't have any doubts. If you have any doubts, please type it in the chat and I'll explain them. Right, okay, so someone asked me to code in Python as well. Right, okay, so for everyone who's coding in Python, let me just, this is the same way you define the two things, what SL, which is steps and location. If steps equal to n and location equal to 0, return 1. If dp of s of l not equal to minus 1, return it. dp of s of l equal to 0 for I in continue. Because of I plus 1 comma, right, s plus 1, my bad, s plus 1 comma I, and again you have to take mod because the answer might be too large, and you return this. Right, I hope this function is clear for people who code in Python and not C++. Right, okay, so someone asked me to explain briefly again. Okay, so the question says that you start at O and you can perform n steps. You can either go to A, B or C. Everything is connected to each other. So at the end of, you can perform n steps, and at the end of n steps, how many ways how many ways do you remain at O again? Like, will you come back to O, reach back O with n steps? So first we form this recursive tree. This is how you first approach any problem. Try to find a recursive solution to it, right? Like, you are starting at O, you can go to A, B, C. Try drawing out this tree, it might be helpful for you. So A, B, C, and then A you go to O, B, C, and so on. And you can realize this subtree and this subtree will be the same thing, so you don't have to calculate it again. You can just cache this value and keep it. And the way you do it is something called memoization, where you just store okay, so suppose, okay, so the subtree of this A and the subtree of this A will be different because they are at different steps. So the things that make the subtree same are if they are at the same step and they have the same location, their subtrees will be the same. So how you cache it is you have a DP with steps and location, and you just store the value instead of computing it again. So right here, so if you've already, like, -1 means you have not computed the value, and if it's -1, then you just compute the value of the subtree. If it's not -1, you just return the value. So basically you are storing the value that you've computed before and not computing it again. So it saves a lot of time, and the time complexity I'll explain again. So the time complexity of the recursive solution is basically the time complexity, is the product of its states. Here S can go from 0 to 1e6, 1 to 1e6 as given here, and L can only be OABC, so L can only be 4, multiplied by the complexity of this function, which essentially is just a for loop with 4. So it's n into 4 into 4, which is equal to 16n. You can ignore the constant and it will be just O of n. I hope this was clear, and how you calculate the states of the DP also was clear. Because states of the DP, you just have to check like what in all values are repeating, like which in all subtrees are the same. If they are the same, like you can cache them. Here these both A's are different because they are at different steps, right? So you need to store steps as well, because you need to know which A's are the same, and you need to store the location because subtree of the B and subtree of the A, even though they are at the same step, is different. So you need step and location, and that's how you calculate the states of the DP. Like you need to know what and all you need to see if the subtrees are same. I hope this clears your doubt. Right, does anyone have any more doubts? Right, okay, so someone says from 0 we can go to 3 places, from which we can go to 3 places further, but the second last step we can't go to 0. I'm not exactly sure what you mean by that, because like if you have A, B or C in the second last step, you can go to 0 with in the last step. Like you can go to O from it. Only if you have O, you cannot go to O in the next step as well. Right, okay, so someone wants me to explain again, so let me just briefly explain. So how you calculate DP is that you need to check which, like after building this tree, you need to check what and all subtrees are the same thing, right? So take these both A's. These both A will have different subtree, like, okay, so just take this, the subtree of this A is this, right? And the subtree of this A is just the A. You can see the subtree of A is different, but if you take a at the same level, you can see the subtrees are the same, right? And the subtree, so you need to have this steps as a state in the DP, because different steps will have different subtrees. And one more thing that you need to have in the DP is like the subtree of the A and subtree of B are not the same, as you can clearly see. Like subtree of A is A, subtree of B is B. So you need to store the location as well as another state in the DP. So these both will be the states in the DP. If you have the state and location, like 2 comma, like suppose the step is 2 and the location is A, these both subtrees will be the same. So these both states are enough to calculate the DP. Is this clear? I'm not sure what exactly you mean by permutation. If you could elaborate on that, maybe I would understand what you're trying to say. Like, okay, so what a permutation is you given n elements, you can permute it in any way. Okay, so suppose you, but here the n elements aren't fixed. Like suppose you have O and A, right, and O and B. These both have two different permutations. Right, okay, so the recursive solution, someone wants me to explain the loop part. Yeah, so in from the current state, right, so let me just let NL is the next location, your current location. If the current location is the next location, you cannot go to it because you have to go to some other thing which is not the current location. So from dp of steps and the location, you can go to step plus 1 with the new location. The new location can be either 0 1 2 0 1 2 3, but it cannot be the same as your old location. Right, okay, so in the C++ code, someone asked me where I call the recursive thing. I call it over here inside the loop, right? So this recursive solution was just, you know, like to explain about dp and how you think about the recursive solution. I didn't implement this because the memory complexity of the recursive solution cannot be optimized. If you want to optimize memory, you usually go for an iterative dp, right? So the difference between a recursive dp and an iterative dp is that in a recursive dp, you see from the current state which in all states you can go to. Like, let me just write it out. So suppose you are in state S1 and you can go to S2 and S3, right? So you from in a recursive dp, you go from S1 to S2 and S3, but in an iterative dp, you check for a current state S1 what in all states you can come to it from. Like S1 can come from like S2 over here. Suppose S2 can come from S1, maybe it could have come from S0 as well. So this is the difference between recursive and iterative dp. So recursive, you just check from the state what in all states you can go to, and an iterative dp, you check from what in all states you can come to this thing. So in the recursive dp, from step comma location, I go to step plus 1 comma location, right? And the iterative dp, you come to 0 from either 1 2 or 3, and here as well, like you come to 1 from either 0 2 or 3. So that was the difference between the iterative and the recursive one. I hope this is clear. Right, okay, so why do I swap dp with new dp, right? Okay, so suppose I have dp of s minus, like dp of s comma l. We calculate this from dp of s minus 1 comma a few other locations, right? New now after we finish calculating this, the s plus 1 of some location comes from this, right? Sorry, so s plus 1 comes from this. So what you can see is after we finish calculating dp of s, now s becomes s plus 1, right? So you make s as the old dp and s plus 1 as the new dp. So right now this would be new dp, and this would be dp, right? For the next state, you need this as the new dp and this as the dp. So I'm basically essentially what I'm doing by the swap function is I'm making this from the new dp to the dp, and make this will be the new dp again. So that's why we swap, because we just discard the state as we don't need it anymore after computing this. So that's what the swap function does. I hope I've clarified all your doubts. So do let me know if you have any doubts or if everything's been explained. Okay, so I don't see any more doubts. I think I've cleared all the doubts. I hope you guys understood whatever I explained here, and thank you for joining this. Okay, thank you guys. I'll be ending the stream now.